This tutorial will show some of the valuable tools CSI Bridge offers when designing pre-stressed concrete box bridges. The bridge we will review will be a single-cell, flat-sided box girder, 28 feet wide. It has two 100-foot-long spans and is 6 feet deep. The deck is modeled with area objects, although the design procedure in this tutorial is also applicable to bridges modeled as spines or solids. Pre-stressing tendons are located in the girders of the box section. And it supports 2 lanes of traffic. Before we start the design, we will first review a few details of our model, starting with the tendons. We go to the Bridge tab and select the Prestressed Tendons button. We have a total of 2 tendons, 1 in each girder. Select either tendon as they are both the same, and click the Modify Show button. Each tendon has a force of 800 kips and is modeled as an element. Click the Show All Tendons button, and we see that at the bridge end, the tendons are located near mid-depth. As we scroll, the tendons move in the deck depth and at mid-span are near the top, returning to mid-depth at the other end. Now we go to the Analysis tab to review the load cases. For this model we have 3, dead, a moving or live load, and pre-stress. Our moving load uses an HS20-44 truck load. We can now run the analysis. Once the analysis is complete, we can focus on bridge design. We start by going to the Design Rating tab and clicking on the Code Preferences button. Here we can select the code, and we will use AASHTO LRFD 2007. Next, click the Add Defaults button in the Load Combinations panel. Select the Bridge Design option, and then click the Set Load Combination Data button. The form lists all of the strength, service, extreme event, and fatigue limit states defined by the AASHTO LRFD 2007 code. To keep the number of design load combos to a relative minimum, in this example we will pick only the strength 1 and the service 2 limit states. If we click on the limit state drop-down list, we see that these 2 limit states are available. Click on the strength 1 limit state, and the load cases that will be used in the design combinations are shown. For the strength 1 limit state, the code specifies 2 design combinations, 1.25 dead plus 1.75 moving load plus 1.0 pre-stress, and 0.9 dead plus 1.75 moving load plus 1.0 pre-stress. Click on the service 2 limit state to similarly see the load cases that will be used in the associated design combination. For the service 2 limit state, the code specifies 1 combination, 1.0 dead plus 1.3 moving load plus 1.0 pre-stress. Click the OK button twice and use the dialog box launcher to view the list of the design load combinations. In addition to the combinations just discussed, the program also creates group combos. For instance, we see a strength 1 group followed by 2 strength 1 combinations. Select the strength 1 group and click the Modify Show button. We see that the group combos are simply envelopes of the associated design combinations. Select the first strength 1 design combo And we see that this combo is as previously discussed, 1.25 dead plus 1.75 moving load plus 1.0 pre-stress, combined in an additive manner. We will quickly verify the other combos. Note that this example contains few load cases and few limit states. Most bridge models will contain substantially more of both, and thus the number of design combinations can be significant, in the hundreds or even higher. Now that the design combinations have been set, we will define the design requests. Design requests are where we specify the type of checks we want to perform. For this model, we will do checks for the entire bridge, although the program allows you to specify checks for only a portion if so desired. We will create a total of 4 design requests for our concrete box girders. 1 for concrete box stress, 1 for concrete box shear, 1 for concrete box flexure, and 1 for concrete box principal stress. Since our deck is a single box, we will not do any multi-cell checks in this example. However, if we did select this option, we then would have the choice of using a single lane with code factors to distribute the live load, or we could input distribution factors directly, or have the program use the girder forces as obtained directly from the analysis. Starting with the concrete box stress, we will specify the demand set to use. Typically, one specifies only the group combination, as this envelopes all the design combinations that are part of the particular limit state. For this demand request, we will select Service to Group as the demand set combo. Our second design request will be for principal stress. And again, we select the Service to Group as the demand set combo. The next design request will be for flexure, and here we select Strength 1 group as the demand set combo. The last design request will be for shear, and again typically we would select the Strength 1 group as the demand set combo. Alternately, we could specify both Strength 1 combinations as the results would be the same. Now that we have specified our 4 design requests, we are ready to run the design. Click the Run Super button, and on the Perform Bridge Design Superstructure form, note that we have the 4 design requests and the desired action. Click the Design Now button to start the design. Principal stresses may take a significant amount of computational time. Upon completion of the design, the Bridge Object Response display form is shown. With the design rating option selected, we can view the checks for the various design requests. Starting with Design Request 1 for the Service to limit state, an envelope of the stresses along the bridge is generated. In this case, for the longitudinal stress at the top left. To see where this envelope falls with regard to allowables, we can check the tension limit and compression limit checkboxes. Using the drop-down list, we can select other locations for the stress envelopes. It appears that these stresses just exceed tensile allowable limits, and therefore it might be desirable to increase the pre-stressing. Design Request 2 shows that the envelopes for the Service 2 limit state appear to be right at the tensile limit. We can also view the Bridge Object Response Display form by going to the Home tab and clicking on the Show Bridge Superstructure Forces Stresses button. Selecting Design, and then Design Request 3, we see a plot of moment along the entire bridge for the Strength 1 limit state. Click the positive resistance and negative resistance options, and we see that the moment lies within allowable values. Select Design Request 4, and we see a plot of shear demand versus capacity along the length of the bridge for the Strength 1 limit state. Note that the demand is below 1, which is obvious with the demand capacity limit checkbox checked. We can also view the required shear rebar area, the torsion rebar area, or a combination of both, and also view results for the webs, if so desired. All of the information displayed graphically in this form is also available in tabular format via the Show Table button. Switching back to Design Request 1 and clicking the button, we see all the stresses along with the governing combinations. This concludes this tutorial.